Hello guys, in this video I'll show you how you can use the IC CD4017. So this IC is a decade counter, meaning it can count from 0 to 9 or 1 to 10. So we have 10 pins over here, which is Q0 to Q9, and these 10 pins are connected to an LED for demonstration purpose with a current limiting resistor. So on the left side you can see 3 pins which control the counting mechanism. One is the clock signal and the other is enable, and the third one is reset. So this clock signal is very important for the counting to happen. Whenever the clock signal goes high, the counting just gets added up. For example, when it goes high, it moves from 0 to 1, and when it goes high again, it moves from 1 to 2. So to show you that working, I have used a logic state. So let us connect this clock signal with this logic state. And turn on the simulation. As you can see, nothing happens because the clock signal is in 0. So whenever I make it 1, it goes to the next. So from Q0 to Q1 it has shifted. So let me make it 1 again, and it goes to the next, and 1 again, and whenever the clock signal goes high, the counting moves on to the next digit. So when it goes to 9, and when we increase the clock pulse again, it goes back all the way to Q0. You should also notice the pin CO. So let us take a pin take a look on this pin CO, which is a carryover pin. This pin will stay high as long as the counting is in the first half. So Q1 is in first half. So Q1, Q2, Q3, Q4, and the first half is over. 0, 1, 2, 3, 4 is the first half, and when it moves to the second half, you can notice that the carryover pin is going low. So and it will stay low for the second half. So the second half is up till Q9, and when it goes back to Q0, it will go on again. So this pin is called a carryover pin. It will indicate if your counting status is in the first half or in the second half, and it will really come in handy for some of your projects. And let us remove this logic state now, because no one will use a logic state to increase the counting. They will actually use a clock source like a 555 timer, or they will connect it to a microcontroller and change the output pins so that the IC works with a particular, the counting happens in a particular speed. So here I have a clock signal which is of, so this clock signal is of 15 hertz, but you can use this up to 5 megahertz. So you can decide the frequency whichever you want, but I have decided it to be 15. So let me go ahead and run the simulation now. And as you can see, the counting happens really fast. This is because of a very high clock frequency. You can notice the 14th pin flashing very fast over here. So this 14th pin is going high and low very fast because of the fast clock signals, and so is the counting happening very fast. Now let us see the function of the two other pins, which is enable and reset. So when the counting is happening, if I just make this enable pin go high, the counting will get passed at that particular position. For example, when I clicked on the enable pin, the counting was at Q3 at that particular point, so it is just being passed at that position. Now if I make it low again, it continues with the clock signal, but when I make it go high, irrespective of the clock signal, it just stays wherever it was in the previous position. So let us take a look at the reset pin now. As the name suggests, this will reset the count back to 0. So when I make it 1, it will reset it to Q0, and it will stay there as long as it is 1. So whenever you want to reset the count, you can use this pin. So this is how the IC works, guys. If you want to know more about it, like the pin details, pin description, or the circuit diagram and all those stuff, you can click on the link in the description to get the complete explanation of this IC. Thank you.